Somewhere beneath the gray waters of the Baltic Sea, a machine is building something that has never existed before. Not a bridge, not a bored tunnel, something far stranger. A tunnel made of enormous concrete boxes, each one longer than 2 football fields and heavier than 50,000 cars, placed one by one into a trench cut into the seabed, joined together end to end, and buried under millions of tons of stone. When it is finished, you will be able to drive from Germany to Denmark in 10 minutes, or catch a train and be there in 7. Today, you take a ferry. It takes 45. The difference between those two numbers is what this project is about, and the story of how it is being built is one of the most extraordinary engineering stories on the planet right now. This is the Fehmarnbelt Fixed Link, an 18-kilometer tunnel under the strait between the Danish island of Lolland and the German island of Fehmarn, connecting Scandinavia to Central Europe by a fixed link for the first time in history. When it opens, it will be the longest combined road and rail immersed tunnel ever built on Earth. And as of this year, it is being built. Elements are going into the water. The trench is cut. The factory that made the pieces is the largest concrete production facility in the world. And the story of how a project that was proposed in the 1990s, delayed by politics for decades, and hit by unexpected technical challenges, is finally taking shape in the mud of the Baltic, is stranger, more ambitious, and more impressive than almost anyone outside the engineering world knows. Let's start with the geography, because the geography explains the need. The Fehmarnbelt is a strait in the Baltic Sea, about 18 kilometers wide at its narrowest, separating the southern tip of Denmark from the northern coast of Germany. It is not a dramatic body of water. It is relatively shallow, about 30 to 40 meters deep, and on a clear day, you can see from one shore to the other. For centuries, the only way to cross it was by boat, and for most of modern history, that meant a ferry. Today, ferries still run between the German port of Puttgarden and the Danish port of Rødbyhavn, a crossing that takes about 45 minutes under good conditions. But those 45 minutes add up. Every day, thousands of trucks, cars, and passengers make this crossing on the route between Hamburg and Copenhagen, one of the main arteries of Northern European trade. Every truck on that ferry is a delay. Every ferry ticket is a cost. Every 45-minute crossing is, in aggregate, an enormous economic drag on the freight flowing between Scandinavia and the rest of Europe. The tunnel exists to eliminate that drag entirely. The decision to build it was not made quickly. Politicians in Denmark and Germany had been discussing a fixed link across the Fehmarnbelt since the 1990s. For years, the debate was whether to build a bridge or a tunnel, and eventually, a tunnel was chosen. Partly because the strait is a busy shipping lane and a bridge would be a hazard to tall vessels. It wasn't until 2019 that Germany gave the formal green light. Construction on the Danish side began in 2020, on the German side in 2021. By the time the first shovel went in, the project had been in planning for roughly 3 decades. So what exactly is being built? Because the Fehmarnbelt tunnel is not being constructed the way most people imagine tunnels are built. There is no giant boring machine grinding through the rock beneath the seabed the way the Channel Tunnel was drilled. The geology here would not permit it. The seabed is composed of soft glacial sediments, not the firm chalk that made the Channel Tunnel possible. Instead, engineers have chosen the immersed tube method. Dig a trench in the seabed, manufacture the tunnel in sections somewhere else, float the sections into position, lower them into the trench, join them together, and bury them. It is, in concept, a bit like assembling a very large and very expensive set of Lego in the dark at the bottom of the sea. The tunnel is being built from 89 separate concrete elements. Each standard element is 217 meters long, roughly the length of 2 football pitches end to end, and when filled with seawater, weighs around 73,000 tons. Each one contains 2 road tubes and 2 rail tubes side by side, plus a central service and escape corridor between them. The cross-section of each element, if you could see it from the end, looks a bit like a hand with 4 fingers. 4 parallel tunnels sitting next to each other inside a single concrete shell. When all 89 elements are joined in sequence on the seabed, the result is a continuous 18-kilometer link between Germany and Denmark, carrying 4 lanes of road traffic and 2 rail tracks simultaneously. To make those 89 elements, engineers built what is now the largest concrete tunnel production factory in the world, constructed on a specially reclaimed piece of land at Rødbyhavn on the Danish island of Lolland. The factory has 3 enormous production halls, each with multiple production lines running parallel. Inside, enormous steel molds are filled with specially formulated concrete, then fitted out with electrical cabling, drainage, ventilation ducts, and everything else each segment needs before it goes in the water. When an element is finished, it is floated out of the factory on a shallow internal harbor and then towed into position in the strait by specialized vessels. The factory has been producing elements since 2022, and as of mid-2025, 15 elements have been completed, representing the first 2.7 kilometers of the tunnel's length. The factory will keep producing until the end of 2026. But manufacturing the elements is only part of the challenge. The trench they sit in had to be dug first, and that was a project in its own right. Over several years, a fleet of up to 60 dredging vessels worked across the strait, excavating an 18-kilometer channel in the seabed. In total, they removed almost 15 million cubic meters of soil, stone, and sand, enough to fill 6 million standard shipping containers. That material wasn't wasted. The dredge spoil has been used to reclaim approximately 300 hectares of new land around the project portals in Denmark, and the new coastline has been reinforced with 2 million tons of Norwegian granite. Where there was open water, there is now new ground, new nature areas and habitat created as a direct byproduct of the tunnel construction. The excavation of the trench, which was completed in 2024, resulted in a channel ready to receive the tunnel elements. And at the bottom of that trench, a specially mixed gravel bed was prepared to receive each element at exactly the right depth and alignment. And then comes the hardest part, actually lowering the elements into the trench. This requires a purpose-built vessel of extraordinary capability, a ship designed specifically to pick up a fully concrete tunnel element weighing 73,000 tons, maneuver it precisely into position over the trench, lower it to the correct depth, and connect it to the element before it with absolute accuracy. The vessel built for this task is called Ivy, and Ivy, it has to be said, has become the source of the project's greatest headache. The completion and testing of Ivy ran into serious technical problems, pushing its readiness back by nearly 2 years from the original schedule. That 2-year delay cascaded through the entire project. By late 2025, the Danish and German transport ministers met to confront the reality. The 2029 opening date was no longer achievable. As of 2026, the project is running with a revised target in the region of 2032, and detailed planning is still underway to firm up the new timeline. But here is what is easy to lose in the story of the delays. The immersion has actually begun. In May 2025, the first tunnel element was successfully submerged into the Fehmarnbelt and connected to the Danish tunnel portal. That is not a small thing. It is the moment the project crossed from preparation to assembly, from manufacturing to the actual act of putting the tunnel together underwater. When you lower a 217-meter, 73,000-ton concrete element to the bottom of the Baltic Sea, align it with centimeter precision against the element before it, drain the water from the connection joint, and confirm a watertight seal, you have achieved something that tests every discipline in engineering simultaneously: structural, geotechnical, marine, mechanical, and logistical. The first connection held, the tunnel is real. And to understand what is being built underground, consider what the experience of driving through it will be like. You approach from the German side, on Fehmarn Island, and descend through the tunnel portal down a gentle ramp into the ground. The road goes underground, beneath the town of Puttgarden, and emerges into the immersed section. Inside the tunnel, the road is straight and level for the vast majority of the crossing. The seabed in this part of the Baltic is relatively flat. Each of the 2 road tubes carries 2 lanes of traffic in one direction. On the other side of the central service corridor, the two rail tubes carry high-speed trains in both directions. The train journey from portal to portal will take roughly 7 minutes. And then, you rise up the ramp on the Danish side, emerge from the ground, and you are on lowland. The bigger transformation is what the tunnel does to the journey times beyond the strait itself. Copenhagen to Hamburg today takes somewhere between 4.5 and 5 hours by car, depending on the ferry crossing. With the tunnel open, that time will fall to somewhere around 2.5 hours. By rail, the reduction is even more dramatic. A high-speed train journey from Copenhagen to Hamburg, currently around 5 hours including the ferry, is expected to drop to around 2.5 hours as well. That is a reduction in travel time significant enough to change how people think about the relationship between the two cities. Cities that are 2.5 hours apart by fast train are functionally in each other's orbit in a way that cities 5 hours apart simply are not. Hamburg and Copenhagen have never been in each other's orbit in that sense. The Fehmarnbelt Tunnel will put them there for the first time, and the effects extend beyond those two cities. The tunnel is part of a larger corridor, the Scandinavian Mediterranean Corridor, one of the European Union's core transport network axes, running all the way from Helsinki in Finland down through Sweden, Denmark, Germany, and into southern Europe. Today, that corridor is broken at the Fehmarnbelt, forcing all freight and passengers onto the ferry. When the tunnel opens, the corridor becomes a continuous, fixed link. For freight in particular, the potential is enormous. Trucks that currently queue for ferries, burn fuel waiting, and incur delays at every crossing will be able to drive uninterrupted across the strait. Rail freight, which today has to be loaded onto ferries to cross the strait, will be able to run directly from Scandinavia to Central Europe without interruption for the first time. The European Union has recognized this strategic importance with substantial financial support, contributing over 200 million euros in grants through its Connecting Europe Facility program. The project is financed in an unusual way. The tunnel itself is not being paid for by direct government grants. It is user-financed, meaning that the cost is being covered by loans that will be repaid over decades from the revenue collected from tolls on vehicles and rail operators using the link. This is the same model used for Denmark's two other major fixed links: the Great Belt Link across central Denmark, which opened in 1997, and the Øresund Bridge between Copenhagen and Sweden, which opened in 2000. Both of those projects were also user-financed, and both are now generating enough revenue to service their debt. The Fehmarnbelt Tunnel, at a construction cost of approximately 7 billion euros, is substantially larger than either of its predecessors. But the same principle applies. The traffic volumes are expected to be sufficient to make the economics work over the loan repayment period. And in a detail that says a great deal about the ambition of this project, the construction waste, the 15 million cubic meters of material dredged from the Baltic seabed, will not be dumped. It has been used to build entirely new coastal landscapes on both sides of the strait. On the Danish side, new wetlands and nature reserves are being created from the dredge material. The project is, in effect, adding land to Denmark as a byproduct of building the tunnel. The environmental assessments for the project took years and resulted in extensive mitigation measures, construction barriers, habitat restoration. Because the Baltic is an ecologically sensitive sea, shallower and less salty than the open ocean, home to harbor porpoises and a range of species that need careful management during construction. The people building this are already doing something nobody has done before. The immersed tube method has been used for other tunnels around the world, but never at this scale, never in this combination of road and rail, and never with elements this large. The sheer size of the individual tunnel elements pushes the limits of what concrete manufacturing, marine engineering, and precision underwater construction can do simultaneously. Every element that goes into the water is a new world record for the weight of a prefabricated structure ever placed in an open seaway. And there are 88 more to go. When the last element is joined, the tunnel sealed, the systems tested, and the first trains and vehicles make the crossing, the Fehmarnbelt will have been closed for the first time in geological history. For tens of thousands of years, Since the last ice age carved these coastlines, the water between Germany and Denmark has been open sea. The tunnel will not close it in any physical sense. Ships will still sail over it, but it will make it, for practical purposes, irrelevant. Drivers will cross without noticing. Trains will pass under the seabed in minutes. Two countries that were separated by water will be joined by something that will last, if well maintained, for a century or more. Somewhere in the Fehmarnbelt right now, in the cold, green water 40 meters down, a tunnel element is sitting on the seabed, its end sealed with a steel bulkhead, waiting for the next one to be lowered into place beside it. The concrete is curing, the instruments are monitoring, the joint is holding. And the engineering story of this decade is being written in a language of pre-stressed concrete and precision dredging, 70,000 tons at a time, on the floor of the Baltic Sea. If a story like this fascinated you, hit that like button and subscribe, because we are only just beginning to uncover the impossible places and the impossible machines that are reshaping our world. We'll see you in the next one.